In this video, I'll show you how to calculate the output power in a simple circuit. We have a circuit with a sinusoidal power source and two 50 ohm resistor. We also have two current probe, one of them for the input and another one for the output. And also we alternatively choose this power probe from the ADS to calculate automatically the output and input power. First, I'll explain a theory behind this calculation, and then I'll show you how to use both methods step by step. The theory is quite simple. The power S is half of the voltage multiplied by the conjugate of the current at a specific point in the circuit. In our case, the amplitude of the sinusoidal voltage source is 10 volts. And the RMS voltage can be calculated by dividing the peak voltage by the square root of the 2. And finally, the power can be calculated using the formula P is equal to V2 over R. The input power is calculated to be half of the watts. Now let's run the simulator and compare the theory and the simulation result. First, let's look at the input and output voltage signal in the time domain simulation. The input voltage amplitude is 10 volt, and since we have two resistors in series, the input voltage is divided into half at output. This is also the same for the power. Half of the input power is dissipated on this resistor and the remainder on this. This diagram is the power signal. The peak power is 1 watt, and to calculate the RMS power, we simply divide that by 2. It is also important to note that the frequency of the power signal is double the input frequency. So if the input voltage signal is at 1 GHz, the power signal will be at 2 GHz. You can see this clearly in this diagram. And let's do the same in the frequency domain. The Fs function calculates the Fourier transform of the input power, and the same for the output power. As you can see, the magnitude of this harmonic is at 2 GHz, and it is half of the watt, same as the theory. And the output power is divided by 2 and is 0.25 watts. And finally, let's do the same thing with the current probe and the voltage. The formula is half of the V times I conjugate. If you calculate these things by the equation, the power in both cases, I mean the P in and P out, are half of what we calculate in the theory and what the power probe suggests. I draw V out and conjugate of the V out here. As you can see here, it is not possible to use it. So for the correction, you have to remove this part in both cases. Thanks for watching.